In this example, a car accelerates from rest to 60 meters per hour in 10 seconds. A quadratic equation of the form d equal kt squared can be used to model the distance traveled d meters in time t seconds. For part A, we need, given that when t equal 1 second, the distance traveled by the car is 13.2. Use the model to find the distance traveled when the car reaches 60 miles, and this is actually miles per hour. So we will start by stating when t equals 1, and we have also the distance of 13.2. So we will need to sub into the equation. So we know the equation is d equal kt squared. So that will give us 13.2 equal kt squared is 1 squared. So that will give us k being equivalent to 13.2. Now our completed equation in this scenario, therefore we say d will equal 13.2 t squared, and in this scenario this will be our answer. So if we want to find it at 10 seconds, we say when t equal 10, we have d equal 13.2 t squared. So that will give us, we sub the 10 into the question, so that will be d equal 13.2 multiplied by 10 squared. So that will give us approximately 1320 meters, which is the distance traveled after 10 seconds. For to reach the 60 miles per hour, so we say at 60 miles per hour. Now for part B, we need to write down the range of values of t for which the model is valid. So we say clearly the model is valid for positive values of t only. We are also unsure of what happens after t equal 10, and we therefore cannot use this model past this point, as we are confident with this value, but the higher value we're not so sure. So we say the model is valid for when t is bigger and equal to 0, or bigger and equal to when t is also bigger and equal to 10. So this will be the range and our kind of suggestion for when the model will be valid. So the model is clearly valid for positive values of t. We are also not sure what happens after t equals 10, and we therefore cannot use this model past this point, as we are not 100% sure what will happen. So we suggest the values that remains between 0 and 10, and this will be our answer for this question. In this example, we're asked to create a model for the motion of a golf ball, and the question shown above, and when h is positive. So we have answered previously, So we have answered the parts of A, B, C previously. Now we're looking at mainly the model for the motion of a golf ball. We need to create a valid when H is positive and finding the range of values of X for which the model is valid. So based on in this scenario, we have the H being bigger than or equal to 0, means that in this scenario we would have the 0.36x minus 0.003 x squared will be equivalent to so this will be equated to bigger than or equal to 0. So in this scenario we'll try to rearrange the expression and we'll take x as a common factor. So that will give us 0.36 minus 0.003x and be equated to bigger than or equal to 0. So we're assuming that x is bigger and equal to 0 after the ball is struck. So we need the bracket to be non-negative. So in this scenario we would equate 0.36 to the value of equal to 0.003x. So in this scenario we would have x equal because we have it divided, so that will mean change because we're moving the 0.003 to the other side, so that will change the sign, so it will be x small and equal to 0.36 over 0.003. So that will give us the value being equal to 120, and that will tell us, so we'll say the model is valid for 0 being bigger than or equal in the smaller than or equal to x, and also x being smaller than or equal to 120. So this will be the range of x values that we will find when we try to rearrange the expression for positive values of h, and this will be our answer for this part of the question. In this example, we have also answered the parts of A, B, C, and D. So we say answered previously. And in this part, we're mainly looking at the model for the height of the stone above sea level, given in the previous question, which is shown here. And we need to find that it is valid for from the time the stone is thrown until the time it enters the sea. And we need to find the range of values of t for which the model is valid. So we say when the stone enters the sea, h will equal 0. So that means if we sub 0 into the equation, we'd have 0 equal minus 5t squared plus 5 plus 15t plus 90. So it is all equated to 0. So ideally we multiply the whole equation by minus 5. So that will make it easier for us to work with. So that will give us the equation being t squared minus 3t minus, in this scenario, 18 equal 0. And we can see that we can complete the square for all these expressions. That will give us t minus 6 and also t plus 3 equated to 0. So we'll have either t minus 6 equal 0, so that will give us t equal 6 seconds, so that's the first value, or t plus 3 equals 0, so that means t equal minus 3 seconds. So we can see, so t equal minus 3 or 6, and when t equal minus 3 or 6, the stone hits, let's see, 6 seconds after it is thrown, since the model is only valid for positive for the time after the stone is thrown, which means at t equal 0. So that tells us, therefore model is valid for, we would have the range of 0 being smaller than equal, the value of t being smaller than equal to 0, or smaller than equal to 6. And this will be our answer and explanation in terms of the negative value is not valid, so we mainly use the 6 seconds as we need to think about after 0, and this will be our explanation for this part of the question.